Hello students, in this video we will be solving problem from exercise 7.3. Our question is, find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are 0, -1, 2, 1 and 0, 3. Find the ratio of this area to the area of the given triangle. So this tells us that there are two triangles. Let us draw a figure to understand this problem. So we have two figures over here and one triangle is within the other one. So this is our main triangle, which points have been given as 0, -1, then 2, 1 and 0, 3. Okay, I will name this as A, B and C. Now it says, find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are these. So midpoint will be in the center. So let us assume the center is somewhere here and over here and over here. Okay, so and we'll draw a triangle. I'll put a dotted line over here so that you know where we should focus for this particular problem. Okay, so a triangle is formed by joining the midpoints of the sides of the bigger triangle. We need to find the ratio of this area to this entire area. Okay, basically the ratios of the two. For that we'll have to find the area of this big triangle and the area of this small triangle. We'll give this triangle some name. Okay, like PQR. So let us give this as P and let this be Q and let this be R. And now what we'll try to do is we'll try to find out the coordinates of this point, because in coordinate geometry we can only find out the area of a triangle by if we know the coordinates of the vertices, and we do not know the coordinates of this vertices. So how do we find the coordinates of these vertices? For that we'll have to use something called as a midpoint formula that we've learned before. Okay, in a midpoint formula what happens is we make use of these two vertices to get the coordinates of the midpoint. So from A and B we'll get P, from A and C we'll get R, and from B and C will get Q. Okay, once we've got coordinates of three of them, then we need to find the area of this one. With the help of these three coordinates we'll find the area of the bigger triangle, that is ABC. Once we get area of triangle ABC and area of triangle PQR, we'll be in a position to say what is the ratio of this one area to the other area of the given triangle. So let us first begin by assuming A, B and C, and then the midpoints as P, Q and R. And our first job is to find out the coordinates of the midpoints. Okay, so let us begin our solution. So we assume first, so let A 0, -1, B 2, 1 and C 0, 3 be the vertices of triangle ABC. Okay, now let P, Q, R be the midpoints of AB, BC and AC respectively. Okay, So now we use the midpoint formula to find out the coordinates of P, Q and R. What is the midpoint formula? As per the midpoint formula, we find x comma y this way. So that would be x1 plus x2 upon 2 and y1 plus y2 upon 2. That is the midpoint formula. To find the coordinates of the midpoint, we have x1 plus x2 upon 2, y1 plus y2 upon 2. Okay. So these are the coordinates. x1, y1 are the coordinates of and x2, y2 are the coordinates of the two ends of a line segment, okay, whose midpoint we have to find out. So let us use this midpoint formula to find out P, Q and R. Now we find out the coordinate of P. So that would be coordinate base, and we'll put this as mark this as x1, y1, x2, y2, x3 and y3. So then write down the formula: x1 plus x2 upon 2. This will be y1 plus y2 upon 2. Continuing P, this is how we mark with 3 lines to show that it corresponds to those particular coordinates. x1 is 0 plus x2, which is 2, whole thing upon 2, comma y1, which is minus 1, plus y2, which is plus 1, whole thing upon 2. That gives us coordinates which are 0 plus 2 is 2 upon 2, comma minus 1 up plus 1 gives us 0 upon 2. 2 and 2 cancel, we get just 1. So coordinates of P are 1, comma 0, because 0 upon anything else is also 0. So in this case we get the coordinates of P, and we mark the coordinates of P over here. So that would be 0, comma 1. Right. Next job is to find out coordinate of Q. So I put over here Q corresponds to, so Q would be midpoint of B and C. That means it would be x2 plus x3 whole thing upon 2, comma y2 plus y3 upon 2, and that corresponds to x2 is 2 and x3 is 0, y2 is 1 and y3 is 3 upon 2. Q corresponds to 2 plus 0 is 2 upon 2, 1 plus 3 is 4 upon 2, 2 1s are 2, 2 2s are 4. That is 1, comma 2. So coordinates of Q are 1, comma 2. And last we come to finding coordinate of R. So that would be x3 plus x1 upon 2, comma y3 plus y1 upon 2, because we are taking AC. Now we substitute the values of x3 and x1. x3 is 0 plus x1, which is also 0 upon 2. y3 is 3, okay, plus y1, which is minus 1. So I'll just put minus 1 over here upon 2. That gives us 0 upon 2, comma 3 minus 1 is 2 upon 2. Finally we get R is 0, comma 1, because 2 and 2 cancel, 0 upon 2 is 0. So R is also 0, comma 1 like P. So our next step would be to find the area of triangle ABC from the three coordinates. Just done a minor change over here. This was not 0, 1, this was 1, 0. Now next job is to find out area of triangle ABC and also triangle PQR. So let us first begin by finding area of triangle ABC, and for that I have already marked x1, y1, x2, y2 and x3, y3, so that we can use it for the area of triangle formula. Let's begin finding the area of triangle ABC. Area of triangle ABC equal to half into x1 to y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Close the bracket. Now we'll substitute the values. x1 is 0, y2 is 1 minus y3 which is 3 plus x2 is 2, y3 is 3 minus y1 which is minus 1, so that will become plus 1, plus x3 is 0 and y1 is 0, sorry, y1 is minus 1 and y2 is minus 1. Close the bracket. Half. Now 0 into anything is 0, so I will not bother opening up this. Plus 3 plus 1 is 4, 4 into 2 is 8, plus 0 into anything is also 0. So left with half into 8, cancel, left with 4 square units. So area of triangle ABC is equal to 4 square units. Now we will find area of triangle PQR. So to find area of triangle PQR, once again we will mark this as x1, y1, x2, y2 and x3, y3. Okay. So area of triangle PQR equal to the formula, which is x1 y2 minus y3 plus x2 y3 minus y2 plus x3 y3, sorry, y, this is y3 minus y1, so y1 minus y2. Close the bracket. Half into x1 is 1, y2 is 2 minus y3 which is 1, plus x2 is 1 into y3 which is 1 minus y1 which is 0, plus x3 is 0 into y1 which is 0 minus y2 which is 2. The bracket. Half into 2 minus 1 is 1, 1 into 1 is 1, 1 minus 0 is 1, 1 into 1 is 1, plus 1 and 0 into anything is 0. So here we have, so half into 1 plus 1 is 2, 2 and 2 cancel, and we are left with 1 square unit. Okay. So now we got area of triangle PQR is 4 square unit and area of triangle ABC is 4 square unit and area of triangle PQR is 1 square unit. So let us put that down. Say therefore area of triangle ABC equal to 4 square units and area of triangle PQR equal to 1 square unit. So this implies area of triangle PQR is to area of triangle ABC, because we are asked for the ratios, is equal to Area of triangle PQR is 1 and area of triangle ABC is 4. So 1:4. So this is our answer, because we were asked to find the ratio of this area. This area which was pertaining to the area of the triangle that is formed by joining the midpoints of this big triangle to the area of the big triangle. So that is why it is 1:4 and not 4:1. That is our answer to this. Okay, so if you like watching this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive updates whenever new video is posted. Thanks for watching. See you in the next video.